In the middle of an ordinary August afternoon, the sun is going to disappear. On August 12, 2026, in 3 days, the moon's shadow sweeps across the North Atlantic at more than 2 kilometers per second. Greenland, Iceland, northern Spain, and a small part of Portugal stand directly in its path. Day turns to night, and the sun's pulley corona hangs in a darkened sky. Hundreds of millions more, far beyond that narrow track, will see the moon carve a bite out of the sun. This is the first total solar eclipse over mainland Europe since 1999. Here is the plan. We start with the machinery of an eclipse and 4,000 years of trying to explain it, follow the shadow across the Earth hour by hour, and step inside the Minute of Totality. Then the sun as it looks right now, including the strongest flare it fired in the past month, how to watch and photograph it safely, and finally city by city, with the cloud forecast for each one. Let's start with the machine behind the spectacle. The moon circles the Earth once a month, and once a month it passes roughly between us and the sun. That is the new moon, when its night side faces us, and we do not see it at all. But a new moon alone is not enough for an eclipse. Only when sun, moon, and Earth line up almost perfectly does the moon's shadow, a cone of darkness trailing 400,000 kilometers behind it, actually touch the Earth. That is the moment this animation shows. The lineup locks in, the shadow lands, and somewhere on our planet, the sun goes out. Look closer at that shadow because it has 2 very different parts, and they produce 2 very different eclipses. The inner cone, the umbra, is the region where the moon blocks the whole sun. It tapers almost to a point by the time it reaches us. On August 12, it will never be more than about 319 kilometers wide, a dark coin sliding across the ocean. Stand inside it, and the eclipse is total. Around it spreads the penumbra, thousands of kilometers wide, where the moon hides only part of the sun. That is the partial eclipse, and it is what most of Europe, North Africa, and North America will see. The map on this globe shows both the narrow red ribbon of totality and the vast shaded zones of the partial eclipse around it. Why do the 2 disks fit so perfectly? It is pure, glorious coincidence. The sun's diameter is about 400 times greater than the moon's, but the sun also happens to sit about 400 times farther away. Seen from the Earth's surface, both disks span almost exactly half a degree. No other planet in the solar system gets this show. The moon can cover the sun's blinding face precisely, no more and no less, unveiling the faint silver atmosphere around it. And the coincidence is temporary. The moon drifts a few centimeters farther from us every year, so in the distant future, total eclipses will cease to exist. We live in the lucky window. So, if the geometry is this clean, why isn't there an eclipse every month? Because the moon's orbit is tilted about 5 degrees against the Earth's path around the sun. Most months, the new moon sails just above or just below the sun, and the shadow shoots harmlessly past our poles into space. Only twice a year, when the line where the 2 orbital planes cross, the nodes, happens to point at the sun, can the alignment close completely. That is why eclipses come in seasons, roughly every 6 months, and why any single spot on Earth waits centuries between totalities. A total eclipse is not rare in the world. It is rare where you live. One more piece of the puzzle. Not every eclipse looks the same, because the moon's distance, and so its apparent size, changes along its elliptical orbit. When the moon is near its closest point, its disk covers the sun completely, a total eclipse. This is what that really looks like. France, August 1999, the last time the shadow crossed this continent. And it is exactly what August 12 will deliver. When the moon is near its farthest point, its disk is too small to hide the sun. A blinding ring of sunlight remains around the black moon, an annular eclipse, the Ring of Fire. Here is a real one from October 2023. Spectacular, but never safe for naked eyes, not even for a second, because the sun's surface stays exposed the whole time. And when only the penumbra brushes your location, the moon takes a bite without ever centering on the sun, a partial eclipse, photographed here over Europe in October 2022. That is what most of this continent will see on August 12, everywhere outside the red ribbon of totality. This is what every skywatcher in history actually saw, the sun being eaten alive, bite after bite. And for thousands of years, nobody could explain it. Eclipses were an attack, and almost every culture reached for the same explanation. Something is eating the sun. In India, it was Rahu, the severed head you see here, swallowing the sun and letting it fall out of his neck. In Norse myth, a wolf ran the sun down across the sky. In Java, the demon Batara Kala did the swallowing, and in ancient China, the written word for eclipse was simply the word to eat. And everywhere the remedy was the same: make noise. Drums, shouting, arrows fired into the sky, pots beaten until the sun came back. It always worked, which is exactly why people kept doing it. The first crack in the fear came from Babylon, and it came from bookkeeping. For centuries, Babylonian scribes wrote down every eclipse they saw on clay tablets like these, and eventually someone read back far enough to notice something astonishing. Eclipses repeat. After 18 years, 11 days, and 8 hours, a nearly identical eclipse happens again. We call that interval the saros. It let Babylon forecast eclipses without understanding a single thing about shadows or orbits. Pure pattern, pulled out of centuries of patient record-keeping. And that 8 hours matters. The Earth turns a third of the way around in that time, so the twin eclipse lands roughly a third of the world further west. Then comes the most famous eclipse in ancient history. The Greek historian Herodotus tells us that Thales of Miletus predicted the year an eclipse would come, and that when it arrived, on what we now date to the 28th of May, 585 BC, it fell in the middle of a battle. The Lydians and the Medes had been at war for 5 years. Day turned to night over the battlefield. Both armies laid down their weapons, and they made peace on the spot. And here is that moment as a camera sees it. The day switched off and minutes later switched back on. Imagine it with no warning mid-battle. Historians still argue about whether Thales really predicted it or how. But the turning point is real. This is where people began treating the sky as something you could work out in advance, rather than something simply done to you. Fast forward to 1715 and Edmund Halley, yes, the Comet Man, does something nobody had done before. Using Newton's brand new theory of gravity, he calculates where the moon's shadow will fall across England, draws it on a map, and publishes it in advance. This map, he asked the public to record what they saw and when, so he could check himself. And he was off by only about 4 minutes in time and 30 kilometers in space. And the thing he drew is real. This is the moon's shadow itself, filmed from a NASA research jet as it swept across America in 2017. Night, pouring over the landscape in the middle of the day. Every path map in this episode, including the one we have been flying over, is a direct descendant of Halley's single sheet of paper. And here is a discovery no laboratory on Earth could have made first. During the total eclipse of the 18th of August, 1868, Pierre Janssen pointed a spectroscope at the prominences blazing around the hidden sun. Fountains of plasma like this one, caught erupting on camera by NASA SDO, dwarfing the Earth many times over, and found a bright yellow line that matched no known element. Norman Lockyer, in England, found the same line and made the outrageous claim, this is a new element, and so far it exists only on the sun. He named it helium, after Helios, the sun. It took 27 more years before anyone isolated helium on Earth, the only element discovered in space before it was found at home, and we owe it to a total eclipse. One more first before we leave the history books, and this one is a movie. In May 1900, the British stage magician Neville Maskelyne traveled to North Carolina with a movie camera of his own design bolted to a telescope. 2 years earlier, he had filmed an eclipse in India, and that film was stolen on the journey home. This time, the film survived. What you are watching right now is the actual footage, the first film of a solar eclipse ever made, and very likely the oldest astronomical film in existence. 60 seconds of hand-cranked frames from 126 years ago. Every eclipse video in this episode, NASA's satellites included, is a great-grandchild of this 1 minute of film. Helium changed the question astronomers were asking.
Why wait years for 2 minutes of darkness? Why not watch the sun every single day? In 1904, George Ellery Hale hauled the snow telescope up Mount Wilson in California, mule train by mule train, and founded the first great mountaintop observatory devoted entirely to the sun. The towers in this photograph fed sunlight down to spectrographs buried in the mountainside. Its heirs have never blinked since. This is the sun's surface seething, filmed by the Swedish Solar Telescope in the Canary Islands. Each of those boiling granules is the size of a country. And this is one whole day of the sun in hydrogen alpha light from the National Solar Observatory's worldwide network, the 8th of April, 2024, the day of North America's last total eclipse, with the star under a magnifying glass from dawn to dusk. Now the plan of attack, hour by hour, in universal time. At 5:08 in the afternoon, the umbra touches down in the Arctic Ocean, near the top of the world. By 5:20 in the afternoon, it is racing south across northeast Greenland, crossing the ice sheet in minutes. At 5:44 in the afternoon, it slides off the Greenland coast, across the Denmark Strait, and clips western Iceland. Reykjavík stands in the shadow around 5:48 in the afternoon. Greatest eclipse, the point where totality stretches to its full 2 minutes and 18 seconds, comes at 5:45 in the afternoon over the ocean west of Iceland. Then the shadow commits to the open Atlantic, a dark ellipse tearing southeast across empty water for half an hour. No land, only ships and aircraft. At 6:20 in the evening, it is approaching Iberia, and at 6:28 in the evening, it makes landfall on the north coast of Spain. In the next 2 minutes, it sweeps across Castile, Aragon, and the Valencia region, the sun already low and golden, and at 6:34 in the evening, the shadow lifts off the earth over the Balearic Sea, exactly at local sunset. From first touch to last, the whole continental crossing takes under 90 minutes. Do not take our word for it. This is NASA's own visualization of August 12. The black oval is the umbra itself, racing across the Arctic and the Atlantic. The shaded rings around it are the partial eclipse, in steps of 20%. Watch how small the black spot is against the whole planet, and how far the partial shadow reaches. Before we tour the cities, let me tell you what the last minutes before totality actually feel like, because no diagram prepares you for it. Around 15 minutes out, the light turns strange, pale, silvery, as if someone were slowly turning down the world's brightness. Shadows sharpen, the temperature dips. In the final minute, darkness rushes at you across the landscape from the west. That is the umbra itself, arriving at 2 kilometers a second. The sun's last sliver breaks into a chain of brilliant points, Bailey's beads, sunlight pouring through lunar valleys, then a single blazing point on a ring, the diamond ring. And then it is gone. The corona blooms around a black hole in the sky. Planets appear, the horizon glows orange in every direction, and people around you will gasp, cheer, or fall silent. Then, all too soon, the diamond ring flashes on the other side, and daylight floods back like a wave. Here is the same NASA model zoomed to the 2 places where the shadow meets land. First Iceland in the mid-afternoon, then, an hour later, northern Spain at sunset. These are the coastlines we will come back to at the very end of this episode, city by city, with the cloud forecast for each one. Now let's talk about the star of the show itself, because the sun you will see disappear is not a blank yellow disk. It is a living, churning ball of plasma, and its recent behavior decides exactly what the corona will look like during totality. As of this report, the sunspot number stands near 41, with 3 numbered active regions and 11 individual spots on the Earth-facing disk. The solar radio flux, a day-to-day pulse of overall activity, is running at 94 solar flux units. Every dark spot on this map is a knot of magnetic field bigger than the Earth, and each one feeds the streamers you may see stretching out of the eclipsed sun. Active region 4505 lies 16 degrees north and 80 degrees west of disk center. It covers 20 millionths of the solar disk and contains 3 sunspots. Its Macintosh class is BXO, and its magnetic class is B. During the past day, it produced 5 C-class flares. Active region 4504 lies 19 degrees south and 17 degrees east of disk center. It covers 10 millionths of a solar disk and contains 7 sunspots. Its Macintosh class is BXO, and its magnetic class is B. It produced no flares during the past day. Active region 4503 lies 16 degrees south and 4 degrees west of disk center. It covers 10 millionths of the solar disk and contains 1 sunspot. Its Macintosh class is AXX, and its magnetic class is A. It produced no flares during the past day. Here is today's sun through the eyes of NASA's Solar Dynamics Observatory in extreme ultraviolet light. The glowing loops and bright patches are active regions, arcades of million-degree plasma pinned down by magnetic fields. During totality, some of them may show up as pink prominences peeking around the edge of the moon. In visible light and in the magnetogram, you can see the same regions as dark sunspots and salt and pepper magnetic fields. This is the face the moon will slide across. If a large spot group is on the disk on eclipse day, sharp-eyed observers with certified glasses can watch the moon swallow it spot by spot. And this is the prize itself, the outer corona, imaged around the clock by the SOHO coronagraph, which makes its own artificial eclipse in space. On August 12, for a couple of precious minutes, you will not need a spacecraft. The moon becomes the occulting disk, and this halo appears to the naked eye. The GOES satellites watch the sun in X-rays around the clock, and this chart is the sun's heartbeat over the last 24 hours. Right now, the background flux sits at class B 5.6. The most recent flare peaked at class B 6.1. Flares like these blast the corona into new shapes, so the crown you will see on eclipse day is being sculpted right now, in front of these instruments. And the sun is not just sitting for its portrait, it is throwing punches. This is the strongest flare of the past month, a class M 3.6 eruption out of active region 4493 on July 22, replayed here from NASA SDO, wavelength by wavelength. Watch the flash race through the magnetic arches and the plasma rain back down afterwards. Every blast like this reshapes the corona. The crown you will see around the eclipse sun is being carved by explosions exactly like this one, right now. Between flares, the sun never stops blowing. The solar wind is currently streaming past the Earth at about 404 kilometers per second. That same wind is what stretches the corona into the long equatorial streamers and fine polar brushes that eclipse photographs are famous for. Near the maximum of the solar cycle, the corona bristles in every direction, and that is the kind of corona this eclipse should deliver. Down here, the Earth's magnetic field keeps score. The planetary K-index is currently 2, after a 24-hour maximum of 2.67. If the sun fires a big eruption our way in the next 3 days, this needle jumps, and the nights around the eclipse could even add an aurora to the show at high latitudes, a bonus for everyone traveling to Iceland. And this is why we published this episode so close to the day. NOAA's 3-day space weather outlook now covers eclipse day itself. Forecasters currently put the chance of medium M-class flares at 1% and of strong X-class flares at 1%. A flare during the eclipse would not change what is safe to do, but an active sun means a livelier corona, prominences at the lunar limb, and better pictures. And for the live picture on eclipse day, stay right here. Our daily sun and aurora bulletin on this channel tracks the flares, the solar wind, and the aurora every single morning, eclipse morning included. Now, the part of this episode you are not allowed to skip: your eyes. Staring at the sun focuses its light onto the retina and burns it, painlessly, permanently. So here is the whole rulebook in 3 steps. During every partial phase, everywhere, the entire time, you look only through certified eclipse glasses, the ISO 12312-2 kind, or a proper solar filter. Ordinary sunglasses do nothing. A camera, binoculars, or a telescope without a front-mounted solar filter is worse than nothing, because it concentrates the light. Second, only inside the path of totality, and only while the sun is completely covered, is it safe and wonderful to look with your bare eyes. And third,
The instant the first flash of sunlight returns, the glasses go back on. If you are outside the path in the partial zone, the answer is simple: the glasses never come off at all. A few words for everyone planning to photograph it. The same law applies to lenses as to eyes. During the partial phases, a certified solar filter goes on the front of every camera, phone included. An unfiltered sensor pointed at the sun can be destroyed in seconds. During totality, inside the path, take the filter off, or your pictures will be black. But here is the most honest advice we can give. The best eclipse photos are wide shots: the corona, the dark sky, the glowing horizon, and the landscape in one frame. A phone on a small tripod, filming the whole scene, will capture more of the experience than a telephoto you are fighting with in the dark. Set it up, press record, and then spend totality watching with your own eyes. You can also skip optics entirely. A pinhole in a piece of card projects a perfectly safe image of the crescent sun onto the ground, and so does the gap between your fingers. Now the gear ladder, from pocket money to dream kit. Step 1. Certified eclipse glasses, a couple of euros, with ISO 12312 printed on the frame. They are for your eyes only. Never put them behind a camera, binoculars, or a telescope. Step 2. Solar film, the photographer's magic phrase. A 16-stop ND5 filter sheet cuts sunlight 100,000 times, and one cheap sheet can be cut to fit any lens or phone. One hard warning: ordinary photographic ND filters, even stacked to ND 1000, are not eye-safe, live view only, never a viewfinder. Step 3. A proper white light solar filter on the front of a telephoto lens or a small telescope, from about 30 euros. It turns every partial phase into a crisp portrait of the bitten sun, sunspots included. And Step 4. The dream ticket, a dedicated hydrogen alpha solar telescope like the little Coronado on your screen, from roughly the price of a good camera lens. It shows prominences, filaments, and the boiling chromosphere on any clear day of the year. The eclipse just adds the moon. Settings you can copy tonight. For every partial phase, filter on. ISO 100, aperture around f8, shutter between 1/500th and 1/2000th of a second, focus set manually on the crisp edge of the sun. For totality, filter off, and bracket wildly because the corona spans a huge range of brightness, 1/1000 for the diamond ring and the inner corona, all the way out to a full second for the long outer streamers. Wide lenses want the landscape, 16 to 35 millimeters, a tripod, no flash, ever. And the golden rule: practice on the plain, uneclipsed sun this week. Same filter, same settings, zero surprises on the day. Let's close with proof of what a camera can do, starting at the very beginning. This is the first successful photograph of a total solar eclipse, a daguerreotype from July 28, 1851, exposed for 84 seconds by a photographer named Burkowski at the Königsberg Observatory. Corona and prominences, captured on a polished silver plate, 175 years before our eclipse. In May 1919, Arthur Eddington photographed stars right beside the eclipsed sun and found their positions shifted, starlight bent by gravity, exactly as Einstein predicted. This unassuming plate confirmed general relativity and made Einstein a household name overnight. Eclipse photography does not get more consequential than this. And this is what modern gear delivers: the total eclipse of August 11, 1999, the last time the moon's shadow crossed mainland Europe. Pink prominences at the limb, the inner corona combed into streamers by magnetic fields. On August 12, Europe finally gets its rematch. The trophy shot is the diamond ring, the last bead of the sun's surface blazing on the ring of the corona. It lasts a second or two on each side of totality. Filter off, burst mode, bracket fast. If you miss it going in, you get exactly one more chance on the way out. One more for the wish list: the sun in hydrogen alpha light. A dedicated H-alpha telescope shows prominences, dark filaments, and the churning chromosphere on any clear day, no eclipse required, And during the partial phases, it turns the moon's edge into a razor silhouette crossing a boiling star. In Reykjavík, Iceland, the moon takes its first bite of the sun at 4:47 in the afternoon. For about an hour, the crescent narrows, and at 5:48 in the afternoon, totality begins, with the sun 25 degrees above the west-southwest horizon. The sky falls dark, the brightest stars and planets come out, and the corona, the sun's outer atmosphere, stands revealed around the black disk of the moon. The last contact is at 6:47 in the evening. Iceland has not stood in the moon's shadow in more than 70 years, and the capital gets about a minute of darkness. Icelandic weather changes fast. Check the cloud forecast in the morning and be ready to drive. Even an hour along the coast can mean the difference between overcast and a clear hole in the sky. A good spot: Grotto Lighthouse on the city's northwest tip, a flat sea horizon exactly where the eclipsed sun will hang. Now, the one thing nobody can order, but everybody needs: the weather. Here is the latest cloud forecast for the hour of the eclipse, city by city. The white painted across each map is the predicted cloud cover itself. The forecast for Reykjavík is honest but hard, near total overcast, about 100%. If you can travel, follow the clearer edges on this map. If not, even under clouds, totality will still turn day into night around you. Most of it is thin, high cloud. The eclipse often shines right through that veil. Count on about 15 degrees Celsius and wind near 8 kilometers per hour and an 88% chance of showers. Pack a cover for the optics. Icelandic weather rewrites itself hourly. Treat any forecast as a starting point, not a verdict. In León, Spain, the moon takes its first bite of the sun at 7:32 in the evening. For about an hour, the crescent narrows, and at 8:28 in the evening, totality begins, with the sun 10 degrees above the west horizon. The sky falls dark, the brightest stars and planets come out, and the corona, the sun's outer atmosphere, stands revealed around the black disk of the moon. The last contact is at 9:22 in the evening. Spain has waited for totality since 1905, and the old kingdom of León sits right on the center line. This is a golden hour eclipse. Pick a hilltop or a wide plain with a completely clean western horizon, because every degree of altitude counts this close to sunset. In town, the wide squares by the Gothic cathedral face the evening sun. Better still is any hilltop on the meseta west of the city. And the weather outlook for León is a gift. Essentially clear skies, just 0% cloud cover at eclipse time. If this forecast holds, you can watch from your own street. Count on about 35 degrees Celsius and wind near 7 kilometers per hour. August evenings on the meseta are statistically among the clearest in Europe. History is on your side here. In Valencia, Spain, the moon takes its first bite of the sun at 7:38 in the evening. For about an hour, the crescent narrows, and at 8:32 in the evening, totality begins, with the sun 5 degrees above the west-northwest horizon. The sky falls dark, the brightest stars and planets come out, and the corona, the sun's outer atmosphere, stands revealed around the black disk of the moon. The show runs to the very end of the day. At 9:01 in the evening, the sun goes down still eclipsed. On the Mediterranean coast, the eclipsed sun hangs barely above the sea. Find a west-facing beach or headland. The corona over the water, minutes before the sun goes down, will be one of the most photogenic sights of the decade. The City of Arts and Sciences gives an open sky, but the prize is any west-facing stretch of coast with the sun over the water. The weather outlook for Valencia is promising. Around 30% cloud, scattered fair weather clouds with plenty of open sky between them. Odds are firmly on your side. Count on about 29 degrees Celsius and wind near 8 kilometers per hour. On the coast, watch for evening haze over the sea. A few kilometers inland can be crisper. In Zaragoza, Spain, the moon takes its first bite of the sun at 7:34 in the evening. For about an hour, the crescent narrows, and at 8:29 in the evening, totality begins, with the sun 6 degrees above the west-northwest horizon. The sky falls dark, The brightest stars and planets come out, and the corona, the sun's outer atmosphere, stands revealed around the black disk of the moon. The show runs to the very end of the day. At 9:07 in the evening, the sun goes down still eclipsed. The Ebro Valley has some of the best summer evening cloud statistics in Spain, which makes Zaragoza a favorite among eclipse chasers. Again, the rule is simple: a flat, unobstructed view to the west-northwest, and you get totality in a sunset sky. The Ebro riverbank by the Basilica del Pilar looks straight down the river toward the setting, eclipse sun. The weather outlook for Zaragoza is promising. Around 19% cloud, scattered fair weather clouds with plenty of open sky between them. Odds are firmly on your side. Count on about 38 degrees Celsius and wind near 8 kilometers per hour. The Ebro Valley's dry evening air is exactly why eclipse chasers book Aragon. London, United Kingdom sees a deep partial eclipse. At maximum, the moon covers 91% of the sun. It starts at 6:17 in the evening and peaks at 7:13 in the evening, with the sun 10 degrees high in the west. The last contact is at 8:06 in the evening. That is deep enough to turn the evening light strange and silvery. Street lights may flicker on early. Watch the crescent sun sink toward the western rooftops through certified glasses. Londoners, Primrose Hill's summit has the classic open view west over the skyline. And the weather outlook for London is a gift. Essentially clear skies, just 0% cloud cover at eclipse time. If this forecast holds, you can watch from your own street. Count on about 29 degrees Celsius and wind near 13 kilometers per hour. Paris, France sees a deep partial eclipse. At maximum, the moon covers 92% of the sun. It starts at 7:22 in the evening and peaks at 8:17 in the evening, with the sun 8 degrees high in the west-northwest. The last contact is at 9:09 in the evening. At maximum, only a thin blazing crescent remains low in the west, the closest thing to totality Paris has seen in a generation. The light across the city will turn pale and cold for half an hour. In Paris, the steps below Sacré-Cœur on Montmartre face the sunset side of the city. And the weather outlook for Paris is a gift. Essentially clear skies, just 0% cloud cover at eclipse time. If this forecast holds, you can watch from your own street. Count on about 34 degrees Celsius and wind near 7 kilometers per hour. Berlin, Germany sees a deep partial eclipse. At maximum, the moon covers 85% of the sun. It starts at 7:15 in the evening and peaks at 8:08 in the evening, with the sun 3 degrees high in the west-northwest. The show runs to the very end of the day. At 8:38 in the evening, the sun goes down still eclipsed. The sun sets before the partial phase fully ends, so the last act happens right on the horizon, rooftops, towers, and the eclipsed sun in one frame. Berlin's Tempelhofer Feld, the old airfield, offers a horizon as flat as the sea for the final act. And the weather outlook for Berlin is a gift. Essentially clear skies, just 0% cloud cover at eclipse time. If this forecast holds, you can watch from your own street. Count on about 22 degrees Celsius and wind near 6 kilometers per hour. Kraków, Poland sees a deep partial eclipse. At maximum, the moon covers 64% of the sun. It starts at 7:18 in the evening and peaks at 7:56 in the evening, with the sun 0 degrees high in the west-northwest. The show runs to the very end of the day. At 8:04 in the evening, the sun goes down still eclipsed. From Poland, the eclipse is a low-sun spectacle. The bitten sun sets while the moon is still across it. A clear view toward the west-northwest is essential. Think riverbanks, hills, or upper floors. In Kraków, climb the Kosciuszko Mound, an unobstructed sweep to the west-northwest, high over the rooftops. And the weather outlook for Kraków is a gift. Essentially clear skies, just 2% cloud cover at eclipse time. If this forecast holds, you can watch from your own street. Count on about 23 degrees Celsius and wind near 7 kilometers per hour. New York, United States sees a deep partial eclipse. At maximum, the moon covers 9% of the sun. It starts at 1:07 in the afternoon and peaks at 1:54 in the afternoon, with the sun 62 degrees high in the south-southwest. The last contact is at 2:38 in the afternoon. 9% is a shallow graze. You would never notice it without protection. But with certified glasses, you can watch the moon clip the lunchtime sun high in the southern sky. In New York, any open lawn in Central Park will do. The sun stands high in the southern sky at maximum. The forecast for New York is honest but hard, near total overcast, about 100%. If you can travel, follow the clearer edges on this map. If not, even under clouds you will feel the light dim, and any brief gap shows the crescent sun through certified glasses. Count on about 28 degrees Celsius and wind near 12 kilometers per hour. A midday summer sky in New York usually means fair weather cumulus. Gaps come and go by the minute. Casablanca, Morocco sees a deep partial eclipse. At maximum, the moon covers 87% of the sun. It starts at 6:48 in the evening and peaks at 7:43 in the evening, with the sun 7 degrees high in the west-northwest. The last contact is at 8:20 in the evening. North Africa gets one of the deepest partial eclipses outside the path itself. In the last daylight hour, the sun shrinks to a narrow crescent over the Atlantic. In Casablanca, the ocean esplanade by the Hassan II Mosque puts the crescent sun over the open Atlantic. The weather outlook for Casablanca is a coin toss, about 52% cloud cover. Keep the day flexible. Watch the satellite picture in the morning and be ready to drive an hour toward the nearest gap on the map. Count on about 24 degrees Celsius and wind near 5 kilometers per hour. That is the complete picture. The machine, the map, the timetable, the sun's current mood, and the safety rules. 3 days to go. Check the cloud forecast the night before. Pick your horizon. Pack the glasses. And if the weather beats you this time, almost exactly 1 year later, on August 2, 2027, an even longer totality crosses southern Spain and North Africa. Clear skies, safe eyes, and enjoy one of the greatest shows nature ever puts on. Subscribe for the nightly sky guide and the daily space weather report.